In this video, I want to try to prove the derivative of. I want to try to prove that the derivative of the natural log of x is equal to 1 over x. So we're going to start by using the definition of limits. So let's start by saying that dx of natural log of x is equal to the limit as change in x approaches 0 of the natural log of x plus change in x minus the natural log of x over change in x. Or you might see this as using h's, but it's the same idea. So we can rewrite this by using the laws of exponents as this right here. So the natural log of, I'm going to rewrite it right here. So the natural log of x plus change in x minus the natural log of x, well, we can just divide the things inside the natural log. So this is going to be equal to the natural log of x plus change in x all over x. And we can rewrite this expression as x over x plus change in x over x, which is the same thing as the natural log of 1 plus change in x over x. So let's rewrite our expression with the new, let's rewrite our limit with the new expression that we just derived. So we're going to rewrite this as the limit as change in x approaches 0 of natural log of 1 plus change in x over x, all that over x, or sorry, all that over change in x. Okay, so let's see what we can do here. So from here we can use the laws of exponents. Actually, here, let me rewrite this in a little bit so you can see that we're going to be using laws of exponents. So this is the same exact thing as the limit of change in x approaches 0 of a 1 over change in x times the natural log of 1 plus change in x over x. So we can use the laws of exponents here, and we can rewrite this as the power of the natural log. So let's go ahead and do that. So we have the limit change in x approaches 0 of the natural log of 1 plus change in x over x, all to the power of 1 over change in x. Okay? So from here, let's do some substitution. Let's call, because if right now if we try to derive the limit, we can't, because we're right here, we're going to get 0 and we can't divide by 0. So let's do some substitution. So let's say we have, let's say we have 1 over the change in x. Let's let that equal z, and then actually let's let the change in x over x equal z. So let's say that the change in x over x equals z, and then from here we can derive what change in x equals. Well, zx equals the change in x. All I did was multiply both sides by x, and then, but we want to switch this variable right here. We want to switch 1 over change in x. So let's do that. So 1 over the change in x, well, that equals 1 over zx. Okay, so now we can do some substitution, and we can change our limit to as the limit as the z approaches 0 of our new expression. So let's rewrite it. So so now we have the limit. Let me actually rewrite it right here. So now we have the limit as z approaches 0 of the natural log of 1 plus, well, this thing we said is equal to z, so 1 plus z to the power of 1 over zx. Okay, so I'm going to go right here, so stick with me here. So now we have, so now what I'm going to do now is split up the exponents into two different quantities that are multiplied. So we have natural log of 1 plus z to the power of 1 over z times 1 over x. So this is the exact same expression. I just rewrote it slightly different. Now we're going to reverse the laws of exponents, and we're going to take out 1 over x, and we're going to put it as a coefficient. So let's do that. So now we have the limit as z approaches 0 of 1 over x times the natural log of 1 plus z to the power 1 over z. And since the only thing that is getting affected in this equation is the z, or is the z's, what we can do is put the limit inside, because that's all that matters in this case. So let's go ahead and do that. So now we can rewrite this whole thing as 1 over x. We can just take this, outside of the limit, because it's not going to get affected. So we have 1 over x times the natural log of the limit as z approaches 0 of, let's see, 1 plus z to the power of 1 over z. And you might notice right here, this is really exciting. You might notice right here that we have the limit as z approaches 0, 1 plus z to the power of 1 over z. And this right here is the value e. So the number e. So let's make some substitutions here. So we have, let's write it right here. So we have the limit of as z approaches 0 of 1 plus z to the power of 1 over z. Well, that is equal to e. So we can rewrite this as, instead of all of that, we can write e. So let's do that. So we have 1 over x times the natural log of, well, just e. So, and the natural log of e is just 1. So now we're going to have 1 over x times 1, which is the same thing as 1 over x. Boom, we just proved the derivative of the natural log of x.